All right, continuing in 9.1, this is example 3 here. So this is our first example of constructing a confidence interval for the population proportion P from beginning to end, okay? So this one says, the drug Lipitor is meant to lower cholesterol levels. In a clinical trial of 863 patients who received 10 milligram doses of Lipitor daily, 47 reported a headache as a side effect. Construct and interpret a 90% confidence interval for the proportion of Lipitor users who will report a headache as a side effect. Okay, well, first of all, we can get the sample proportion. We can say there were 863 patients in this particular trial, and 47 of them reported headache as a side effect. So the sample proportion of people who experienced headache as a side effect was 47 out of 863. And that comes out to about, I'm going to round to 3 decimal places, so 0.054. So about 5.4% of people who take Lipitor experienced headache as a side effect in this particular trial, okay? The question is, out of all of the Lipitor users in the world, what percentage of them experience headache as a side effect? We can't say that it's exactly 5.4%, right? But it's probably something close to that, okay? So it's probably 5.4%, give or take a little bit. The exact value that we would give or take, our margin of error, right, would be this. So the formula is p hat. This is just the same formula from the previous page, but it's p hat plus or minus z sub alpha over 2 times sigma sub p hat. Okay? Where z sub alpha over 2 is our critical value, and the alpha in that z sub alpha over 2 is related to our level of confidence here, right? We want to be 90% confident. We want a 90% confidence interval, okay? So if we want a 90% confidence level, then that means that alpha should be 0.10, right? Because 100% minus 90% is 10%. 10% as a decimal would be 0.10. That means that z sub alpha over 2 would be z sub 0.10 divided by 2, which would be z sub 0.05. And we can go to StatCrunch now to figure out what z sub 0.05 is, right? We go to the normal calculator in StatCrunch. Okay, so we're going to go to Stat, Calculators, Normal. To compute critical values, we want areas to the right. And in this case, we want that area to equal 0.05. Okay. So we hit compute, and there's the critical value. Okay. So our critical value is about 1.64. Okay, so let's do this. Let's plug some stuff in. By the way, sigma sub p hat, so this whole interval is p hat plus or minus z sub alpha over 2 times sigma sub p hat. Sigma sub p hat is the square root of p hat times q hat over n. So I'm just gonna plug all of this into the formula, right? So we're gonna say, so my formula, p hat plus or minus z sub alpha over 2 times the square root of p hat times q hat over n. Okay, I know that p hat is 0.054. So I'm going to say this is approximately 0.054 plus or minus z sub alpha over 2 was 1.64 times the square root of p hat, we said 0.054, times q hat. Well, q hat is 1 minus p hat, right? So 1 minus 0.054 comes out to 0.946. Okay, so there's p hat, there's q hat. Divide by n, what was n? 863, right? 863 patients in that trial. Okay, so there it is. There are all the numbers plugged in. Now the rest is just simplifying. Now here's my advice. When you simplify this, don't start here. Right? Don't start with the 0.054. Punch all of this stuff into your calculator first. The 1.64 times blah, blah, blah. Punch all of that into your calculator. Punch it in just exactly the way that it looks. And then write down your answer. And then do a second step to add and subtract. Okay? So I'm going to say this is equal to, or actually I'm going to probably do some rounding. So I'm going to say this is approximately 0.054 plus or minus, and I'm going to plug this stuff into my calculator now. Okay, everyone's calculator is a little different. So this is how I'm going to punch it in. Right? So maybe this helps you, maybe it doesn't. But I'm going to say 1.64 times, whoops, let me try again. 1.64 times the square root. When I hit my square root button, it automatically opens up a little set of parentheses there, right? Which is good. You want it to do that. If yours has opens up a little box, then that's even better. But we would say 0.054 times 0.946 divided by 863, and then close the parentheses. Okay. So rounding that to 3 decimal places, I would say 0.013. Okay, so this is my point estimate. This is my margin of error. If I want to be 90% sure that my interval contains the true population proportion, then my margin of error needs to be 1.3%. Okay? But let's finish this now. Okay? So when I give my answer, I want you to give the answer in interval notation. So you're going to subtract these values and put that answer on the left. Then you're going to add these values and put that answer on the right. Okay? So I'm going to do 0.054 minus 0.013, and I get 0.041. Then I'm going to do 0.054 plus 0.013, and that gives me 0.067. Okay, and that's my answer. Okay, so there's my confidence interval. All right, we were asked to construct and interpret a 90% confidence interval. Well, there's the confidence interval. We need to interpret that now. Okay, it's really easy on these kinds of problems to lose the forest for the trees, right? There's so many details here, so many numbers, and you just get lost in all of the calculation. But what's really, truly important to me that you take away from this is that you can look at a confidence interval and understand what it's saying, right? So here's what this confidence interval is saying. We're saying that we are 90% certain that the true population proportion of Lipitor users who experience headache as a side effect is somewhere between 0.041 and 0.067. Another way to say that, you could say we're 90% sure that somewhere between 4.1% and 6.7% of Lipitor users will experience headache as a side effect. Okay? So again, just to be clear, in our sample, exactly 5.4% of people experienced headache as a side effect. But we're asking what proportion of people, what proportion of all Lipitor users will experience headache as a side effect. We're 90% certain that somewhere between 4.1% and 6.7% of Lipitor users will experience headache as a side effect. That's what the confidence interval means. I think it's pretty amazing. I think it's pretty interesting. This isn't just a guess, right? We're not saying, oh, well, we guess it's somewhere between 4.1% and 6.7%. No, we're exactly 90% certain that it's somewhere between 4.1% and 6.7%. If we wanted to be 95% certain, we could do some calculations and we'd get a larger interval, but we would be 95% certain that that interval would contain the true population proportion. If we wanted to be 99% certain, we could do the same thing. Do some calculations, get a new interval. That interval would be even larger, but we would be 99% certain that it contains the true population proportion. So all of these things are mathematically rigorous. There's no guessing involved here. It's not a guess. We are 90% certain that the true population proportion is somewhere between 4.1% and 6.7%. So we should write down some version of that answer, I suppose, right? Since we were asked to interpret the interval. So our interpretation would be something like this. So we could say something like, we are 90% certain that the true population proportion of Lipitor users who get headaches as a side effect So we're 90% certain that the true population proportion of Lipitor users who get headaches as a side effect is between 4.1% and 6.7%. Okay, there's our interpretation. Let's take a look at the next page.